we talk about today and tomorrow, we're going to kind of bring into Thursday as well. So we're kind of spending 3 days on this same thing in a way. What we're doing today is we're kind of setting ourselves up so tomorrow hopefully is a little bit easier. So tomorrow we're going to talk about graphing and how to graph a linear equation. And one of the big things that we're going to find out tomorrow is that you cannot graph a linear equation if it is not in the correct form. So that's what we're going to work on today. So all we're doing today is writing equations in the correct form. So we mentioned this yesterday, just super briefly, but we have this form of an equation that's called slope-intercept form, okay? And it looks like this, y equals mx plus b. And I mentioned yesterday, we put in our notes yesterday, that if you have the equation in y equals mx plus b, you're not going to see the letter m, you're not going to see the letter b. There's going to be numbers there. Now, you'll see the x and the y, but there's going to be a number here. And remember, the number that's in place of the m, which is always going to be the number in front of the x, is going to be the slope of the line. So what's great about the form of this equation, you know, yesterday we had to work so hard finding change in y over change in x, and or rise over and all that stuff. If it's written in this form, you literally look at the equation, you're like, oh, that's the slope. That's it. You don't have to do change in y over change in x or any of that. Okay? That's the slope right there. And then the b, if you remember from yesterday, is the y-intercept. So this is why it's called slope-intercept form, because by looking at the equation, you can see the slope of the line and the y-intercept. Okay? So how you write an equation in slope-intercept form? You're solving an equation. That's it. Okay? You're going to solve the equation for y, because it has to be in the form of y equals mx plus b. So what our goal is we are trying to get y all by itself on one side of the equation. So one thing that I think is makes it a little bit easier, you guys remember the onion method from like the beginning of the year? Okay, I think if you kind of struggle putting an equation in y equals, or it's tough because we're solving an equation, but it's not all numbers, right? I'm going to solve this equation for y, but there's an x over here, and it gets kind of complicated whenever it looks like that. So this is why I really like the onion method. So if you remember the onion method, the first thing we circle is our variable. Here's the thing. I have two variables. The variable you're circling is the variable you're solving for. I'm solving for y, so I'm going to circle my y. Now, if you remember with the onion method, the next thing we're going to do is we're going to circle all of the operations in PEMDAS order, okay? So this says 4x plus and 3 times. Multiplication comes before addition. So this is what your onion would look like. Remember, you're finished building your onion whenever you have all of your, everything circled on that side of the equation. Then you're ready to peel your onion, okay? So that outside layer is the first layer that needs to go, which is going to be the 4x, okay? So to get rid of the 4x, I need to move the 4x to the other side. So to completely move the 4x to the other side, we're going to subtract 4x. Notice it gets rid of it. 4x minus 4x is gone. But just like anytime we solve equations, if I subtract 4x on one side, I have to subtract 4x on the other. So now I have 3y equals. Now, on the right-hand side, usually I would go ahead and subtract these. Here's the problem. That's a 9 and that's a minus 4x. These are not like terms. You can't combine them together. You have to leave them separate. Technically, it doesn't matter what order you put them in. But here's the thing, guys. If my goal is to put them in y equals mx plus b, it tends to make a little more sense if we get in the habit of writing the x first. Okay? Now, you guys see how the x is a negative 4x? That negative needs to stay in front of the 4. Okay? The 9, if you kind of cover up that minus 4x, that 9 is positive, so it's going to be a plus 9. Okay, ready so far? Okay, the last thing, keep in mind here, I'm trying to solve for y, so I need to get rid of the 3. So just like a normal equation, this is 3 times. So to get rid of the 3, I would divide by 3. Now here's another place you need to be super, super careful. On the right-hand side, you need to divide that entire thing by 3. So it's going to look like this. Okay? Now, on the left-hand side, we get our y equals. Great. On the right-hand side, we talked about this like one day, like the first week of school. You guys remember me mentioning the butterfly method? That's what this is. I don't want to leave my answer like this. To simplify this, I'm going to take negative 4x divided by 3. Can't really take negative 4x divided by 3. So what I'm going to do is I'm going to call it negative 4 thirds, and I'm going to kick the x out of the fraction. It means the same thing. Mathematically, it means the same, but this is going to be helpful whenever we go to graphing, okay? But then when I do the butterfly method here, I can do 9 divided by 3, which is going to be a positive 3. This is an equation in slope-intercept form. Y equals m, hey guys, look, there's your slope, negative 4 thirds. You can just see it, right? And then 3 is going to be your y-intercept, okay? So let's go down here and let's try these 3 examples down here. Okay, so this first one, 5x minus y equals 12. Okay, if you like the onion method, if that tends to help you, remember, I like at least starting with the onion method because it kind of makes you focus in on what you're solving for. I'm solving for y, so I'm going to circle my y. Kind of at first glance, it really only appears there's only one thing to get rid of, and it's that 5x, which kind of in a way it is, okay? But regardless, that 5x is the first thing that needs to go. But be careful here. What kind of 5x is that? It's a positive 5x. You guys see that? So to get rid of a positive 5x, I need to subtract 5x from both sides. When I do that, that negative is still there in front of the y. Now remember, it technically doesn't matter. If you say 12 minus 5x, that means the same thing as negative 5x plus 12, but I think it's going to be more helpful to just get in the habit of writing the x first, okay? Now, I want to solve for y, not negative y. So if this was just any other equation that just had numbers, how would you get rid of the negative? Right, you would divide by negative 1. So you're going to do that. On the right-hand side, always make sure you divide the entire thing by negative 1. So on the left, we get y equals. On the right, just like we did in the last one, we're going to have to do the butterfly method. Negative 5x over a negative 1 would give me a positive 5x. And then 12 over negative 1 would give me a minus 12. So your answer in slope-intercept form would be y equals 5x minus 12. Yes? Okay, so you know how to get rid of the 5x, we subtract 5x minus 5x. The 5 is what's negative. The 12, if you look here, the 12 is positive, okay? You always take the sign that's in front of the number, okay? Does that help? Okay. All right, let's do this one, okay? We're going to solve for y. If you like doing the onion method, it would be 7 times and then 2x plus. So that outer layer is the 2x. It's a positive 2x. So to get rid of a positive 2x, we would subtract 2x from both sides. Okay, the 7y is a positive 7y equals, once again, I like to get in the habit of writing the x first. It is a negative 2x, and the 14 is a plus 14. And then to get rid of the 7 in front of the y, we would divide everything by 7. You're always going to do a big fraction bar over there on the right. So we have y equals, and then we do the butterfly method. So when I do negative 2x over 7, the 2 over 7 isn't going to reduce. So we're just going to leave it as negative 2/7 and then kick the x out of the fraction. And then we'll do a positive 14 divided by 7, which I can simplify into a plus 2. Okay, this is what we're doing today. How we feel about this? Okay? Some of them do get a little tricky, so like this last one. Okay, there's not going to be very many of them like this, but there will be a few, and these ones you have to just be very careful with, okay? We start off the same way. We're solving for y. It'd be 3 times, and then that x. So you're kind of catching on that a lot of these follow the same pattern. The first thing I need to get rid of is the x. Be careful here. What kind of x is it? It's a positive x. So I'm going to subtract x from both sides. When I get rid of the x, it's still negative 3y over there on the left. Okay? Now, the x is a negative x. The 6 is a plus 6. Okay, now, to get rid of the negative 3, we're going to divide everything, divide both sides by negative 3, so we get y equals. Now, this is where it can get a little tricky. On the right-hand side, when you take negative x over negative 3, first of all, a negative over a negative is what kind of answer? A positive. Now, kind of where you're off to the side. If I were to leave it as x over 3, when we get into graphing tomorrow, I'm afraid if you leave it like this, we might not recognize correctly what the slope is. So here's what I want you to do. If you see something like this, you're like, oh, that looks kind of funny, I want you to write the number that's in front of the x that we don't normally write. What number is in front of x that we just don't usually write? A 1. Now what I'm going to do is I'm going to do just like what I did in the other ones. Kick the x out of the fraction, and let's do it as a 1/3 x. Now, this mathematically is the exact same thing as x over 3, but 1/3 x is going to be easier when we get to graphing tomorrow, okay? And then we're going to do 6 over negative 3, which is a negative 2. There we go. That's probably the hardest ones that we'll do today, okay? All right, let's get this glued into page 37 of your interactive notebook. We'll call this 5-3 slope-intercept form. Slope-intercept form. All right, so whenever you guys get to your homework today, I have board problems, so I'll just put them on the board. You guys can copy them down on a piece of notebook paper. It's just kind of saving me from making some copies. But this is exactly what you're going to be doing on your homework. So we want to first write each equation in slope-intercept form, which just means put it in y equals. Then once it's in slope-intercept form, we're going to identify the slope and the y-intercept. Okay, so number 1. Let's start with 3x plus y equals 2. 3x plus y equals 2. Okay. If you like the onion method, great. Even if you don't think you need to do the entire onion method, one thing I might suggest you do, I'm solving for y, so it might be best at least to just kind of identify the y first. This is what you're trying to get all by itself. Now this one should be pretty simple to solve because the only thing over here other than the y is the 3x. That's the only thing you have to get rid of. So I need to move the 3x to the other side. Since it's a positive 3x, I'm going to subtract 3x from both sides. So over here on the left, I get y equals. Now on the right, remember, I like to put the x first. It is a negative 3x, and the 2 is the plus 2. Once your equation's in y equals, that's the first part, okay? The next thing we want to do is we want to identify the slope, which is your m, and the y-intercept, which is your b. Okay? So remember, we're writing these in the form y equals mx plus b. So the m is the number in front of the x. So the slope of this line is -3. Tomorrow when we get to graphing this one, what you're going to see is you're going to see a line that slopes down pretty steeply if we were to graph this one. Okay? And then the b is going to be the other number that's not attached to a variable, so the y-intercept here is going to be 2. So that's what you're going to be doing on your homework today. Okay, number 2, 2x minus y equals 4. Okay, once again, even if you don't want to build the entire onion, what I might suggest, at least find the y. That's what we're solving for. Find your y, circle your y. If you want to circle the rest of it, great. This one's kind of like the last one. There's not a whole lot to get rid of. I've got the 2x to get rid of, and these are the ones you need to be careful. How am I going to get rid of the 2x? Subtract, because this is a positive 2x. So to get rid of a positive 2x, I'm going to subtract 2x. When I do that, that negative is still there. It's still negative y. And on the right-hand side, it's going to be negative 2x plus 4. And remember, we did one of these on the left-hand side. I don't want a negative y. I want a positive y. Just like a normal equation, if there was a number on the other side, to get rid of the negative, we would divide both sides by a negative 1. So we would get y equals, and then on the right-hand side, we do the butterfly method. Then I would take negative 2x divided by a negative 1. A negative divided by a negative is a positive 2x. And then 4 divided by negative 1 would be a minus 4. So the equation in slope-intercept form is y equals 2x minus 4. Once it's in y equals, your slope and y-intercept are super easy to identify. The m is your slope. Okay, and the slope is y equals mx. So what's my slope? 2. And then the b is going to be usually whatever comes after the slope. Sometimes if they're mixed, you got to be careful. But in this case, what's my y-intercept? Negative 4. Okay, you got to include the sign in front. Your y-intercept is negative 4. Okay, number 3. 4x plus 2y equals 6. Okay, once again, might be a good idea, at least circle the y. Okay, that's what you're trying to solve for, at least circle the y. And you're going to kind of notice that most of these kind of follow the same pattern, that the first thing I need to move is that x term. Okay, so to get rid of the x term, we're going to subtract 4x from both sides. When I do that, we get 2y equals, on the right-hand side, I like to put the x first, so I'm going to say negative 4x plus 6. And then lastly, to solve for y, to get rid of the 2, once again, kind of following the same patterns as most of these, we would divide by 2. Make sure you do a big fraction bar over there on the right-hand side. So we have y equals, and then we do the butterfly method. So I would take negative 4x over 2. I can do negative 4 over 2, which would give me negative 2x. And then I would take 6 over 2, which I can divide 6 divided by 2, and we get plus 3. Okay, once it's in y equals, it should be easy to say m and b. What's my slope? Negative 2. What's my y-intercept? M is negative 2. B is 3. Okay, number 4. 3x minus 5y equals 15. Okay, once again, even if you don't build the whole onion, that's fine. You don't have to build the whole entire onion, but at least find your y. Okay, that's what I'm solving for. Because sometimes it's not going to come first. Okay, so it's helpful just to kind of identify here's what you're solving for. Okay, the first thing I'm going to get rid of is the 3x. How are you going to get rid of the 3x? Minus 3x from both sides. Now, when I do that, that negative in front of the 5y didn't go away. It's still in negative 5y. And on the right-hand side, we have our negative 3x and then our positive 15. And then divide by negative 5. Big fraction bar over there on the right. So we would get y equals, and then we do the butterfly method. So I'm going to do negative 3x over negative 5. Okay, now this one, a negative over a negative is what kind of answer? A positive. This time I can't reduce 3 over 5. They're not going to go in evenly. So we're going to leave it as 3 over 5, but what we're going to do is we're going to kick the x out of the fraction, and we're going to call it 3/5 x. Okay? And then 15 over negative 5 would give me negative 3. So once it's written in slope-intercept form, what's my slope? 3/5, always the number in front of x. And what's my y-intercept? Negative 3. Okay, just got a few more for you guys. Okay, number 5. Okay, let's do x minus 5y equals 10. All right, so I'm solving for y. So what's first step here. Excellent. Subtract the x from both sides. When I do that, I still have negative 5y. On the right-hand side, we've got negative x and then a plus 10. Okay, now, these are the ones that I was telling you guys whenever we did that left-hand side that you need to be really careful about. Because when I divide everything by negative 5, okay, we get our y equals. Great. But over there on the right-hand side, I'm taking a negative x over a negative 5. A negative over a negative is what kind of answer? A positive. But if you leave it as x over 5, which mathematically is correct, there's nothing mathematically wrong with that, but whenever we get to graphing tomorrow, I think that's going to cause some problems. So if it's just an x, what I want you to do, we don't usually write the 1 in front of it, but go ahead and write the 1 in front of it. And then, like we did with the last one, kick the x out of the fraction and we'll call it a 1/5 x. And then I'll do 10 over negative 5, which would be a minus 2. Notice, if I write it like this, whenever I go to identify my slope and y-intercept, to find the slope, you just find the x and you look for the number in front of the x. If you had left it as x over 5, it might have been kind of confusing what the slope was going to be. Because there's not really a number in front of x, there's a number under x. See how it could be a little confusing there? But if I look at it like this, it's really easy to say, okay, my slope's 1/5, my y-intercept is negative 2. All right, last one here. Okay, let's do 4y minus x equals 12. Now, number 6 is one that, this is why I like, even if you don't build the whole entire onion, I really, really encourage you guys first, at least circle the variable you're solving for, because this one, I mean, it looks a little different than the last one, right? You see how the y comes first? That's what I'm solving for, okay? We're going to do basically the same thing, it just looks a little different, okay? On the other ones, how I usually move the x to the other side, that's still the first thing I'm going to do. I'm going to add x to both sides, and we get 4y equals, on the right-hand side, I'm still going to write the x first. It's a positive x, and then this is going to be a plus 12. And this one's really similar to the last one. Whenever I divide by 4, we would get y equals. On the right-hand side, when I do the butterfly method, I really don't want to leave it as x over 4 because it's going to be kind of confusing what the slope is. So we're going to write the 1 in front of the x, kick the x out of the fraction, and we'll call it 1/4 x. And then 12 over 4 would give me a plus 3. So the slope of this line would be 1/4. The y-intercept would be 3. Very good.